In this video, we cover the NIRFASTer toolbox. We begin with a brief overview of NIRFASTer, then show how to download, install, and test the software. Lastly, we consider potential problems that can sometimes occur when working with toolboxes such as NIRFASTer that include MATLAB MEX files. Note this video covers using NIRFASTer with a MATLAB version of NeuroDOT installed locally on your machine. The Python implementation, or processing using the Oxy website, are described in separate tutorials. To get started, it's helpful to understand how NIRFASTer fits into processing. In the broadest sense, the NeuroDOT workflow involves combining data collected using an optode array with a model of how light propagates inside the head. These two processing streams converge to produce a volumetric map of brain activity. Because of the complex geometry and non-uniform optical properties of the brain, skull, and scalp, the light model is solved numerically. This is a non-trivial problem. The two leading approaches are Monte Carlo modeling or finite element analysis. Either can be used with NeuroDOT, but here we focus on finite element. Monte Carlo will be covered in a separate video. Fortunately, sophisticated packages for finite element modeling have been made available by several groups in the imaging community. NeuroDOT uses the NIRFASTer toolbox. The software was developed in a collaboration of Kitware, Dartmouth College, and the University of Birmingham. It is a successor to the NIRFAST toolbox and introduces new solvers and expanded capabilities. NIRFASTer is available from the GitHub repository shown here. You may either download the package as a zip file or, if you have Git installed on your machine, by cloning the repository. You'll need to make the package generally accessible if intended for multiple users on your system. See the Getting Started video tutorial for details on setting directory permissions. After download, NIRFASTer must be added to the MATLAB path. This can be done using the Set Path button in the command window toolbar, or by using the Add Path command from the command line as shown here. In this example, we have assumed NIRFASTer was cloned under the directory /applications/toolboxes, or was moved there after a zip download. Use the Save Path command to make the path addition permanent. Otherwise, you will need to add NIRFASTer to the path each time MATLAB is restarted. Here we will call the NIRFASTer function LAreaC to test the installation. This function computes the area of a mesh element given its node coordinates and connectivity. Although in practice a light model will contain thousands of elements, we require only one to call the function. Input the node coordinates and element connectivity as shown, then pass these to LAreaC. If NIRFASTer is working properly, a value of 1/2 should be returned. If MATLAB cannot find the function, check that your path setup agrees with your installation location and that you have permissions to access the directories and files. A second potential problem is considered in the next section. Many of the MATLAB scripts in NIRFASTer are provided as compiled code, more commonly called a MEX file. These functions implement computationally intensive operations, and using compiled code results in a considerable reduction in runtime. A few examples of MEX files included with NIRFASTer are shown here. To the user, a MEX file behaves like any other MATLAB function. The only requirement is that the file must be compatible with your machine architecture. NIRFASTer provides MEX files compiled for Linux, Windows, and Mac operating systems. The target architecture is indicated by the MEX file extension. MATLAB determines which file to use at runtime. The use of MEX files usually presents no difficulties. However, the runtime environment is always somewhat unpredictable, and occasionally there can be problems. An example is shown here, in which the current version of NIRFASTer was installed on a system running an older version of MATLAB. This resulted in a conflict with the available runtime libraries. Fortunately, the issue was resolved by simply recompiling the file in question using the MATLAB MEX compiler. Unfortunately, use of the compiler may require additional software installation, such as GCC or Xcode, as well as library updates or customization of configuration files. Additionally, if the entire code base is affected, individually recompiling all of the source files in a distribution is tedious at best. Some third-party toolboxes include makefiles or other scripts for this task. Currently, however, NIRFASTer does not. MathWorks provides extensive documentation on use of the MakeFile compiler. If you encounter MakeFile issues and are unable to resolve them, the NeuroDOT development team should be able to help. With NeuroDOT and NIRFASTer installed, you are ready to begin data processing. Several PowerPoint tutorials on light modeling and data processing are included with the NeuroDOT distribution. These will give you a deeper understanding of how finite element analysis is used in the processing pipeline. Additional information may be found in the resources listed here. Feel free to contact the development team with questions or post them in the comment section below. Thank you for your interest in NeuroDOT.